Hey.
In this assignment, you should I to treat passively for the most part. Actually, I did that because I
Okay. Gotcha. Oh, request a regrade. I'll give you your points.
This comment. Is that okay?
Send me an email, okay? We don't see the comments when you post them. Okay, ladies and gentlemen, thank you for joining us. It's good to see you. I want to apologize. I don't feel super good today, but I'm going to try my best for you. How many of you were at the career fair today? You saw the career fair outside? No one? A few of you? Okay. Were there any really cool companies? Any XR companies, game dev stuff, anything? What kind of companies were there? What did you see? Military. Do they have VR, AR stuff going on? Maybe? Anyway, always kind of a stressful time, right? And if you need to go to the career fair, you do what you have to do. Remember, these lectures are all recorded, and today's is particularly important. If you are in this course, if you are doing Project 1, today we're going to knock out probably about 75% of your first week's homework on this project, okay? We're going to do that all today. We're going to be programming a lot together today, and we're going to want to move kind of fast. But know that you can always watch the recording again, and that'll help you get through this first part of the project, okay? If you look at where we are right in the middle of that P1 milestone. You've got about 5 days left. Today, we're going to knock out a lot of that work you're going to want to do over the next 5 days. But you also should be working on your P1 project management. You're kind of getting into JIRA. You've taken the spreadsheets that you find in the P1 milestone assignment, and you break them out into JIRA tasks. Okay? I'll talk a little bit more about that in just a moment. We've got some announcements, and I want to show you a company. Okay? This is a super cool company. This is a company called Vicarious Surgical. They're based in Massachusetts, and they've raised around $200 million. So that's a pretty big raise. The idea here is we want to create a robot. We want to create a robot that has the ability... oh, I don't have my mic working. We want to create a robot that has the ability to let us perform procedures remotely. Okay, from across the world, perform procedures in particular in the abdomen area. And I think there's a video in here somewhere. Is there? Maybe. Let's see. Source. Is there a video? I'll play video. Let's take a look.
At Vicarious Surgical, we are inspired by the opportunity to improve patient lives. We are developing next-generation, life-changing medical technology through the blending of robotics, computer science, and advanced visualization. In the operating room, the smallest details make the biggest difference. Surgeons today are limited to standard laparoscopic tools that are straight, have limited dexterity, and require multiple incision sites. Or robotic platforms that have either large, cumbersome architectures with wrist-on-stick technology or a single incision site with low forces and large incisions. Surgeons deserve something better, which is why Vicarious Surgical is reimagining surgical robotics to be less invasive and more capable. With just one small 1.8 centimeter incision, the Vicarious Surgical robot maximizes surgeon abdominal access and visualization. The very core of our innovative technology is our proprietary decoupled actuator that has allowed us to re-engineer single-port robotics and redefine robotic motion with an impressive 9 degrees of freedom per arm. Not only are we able to put wrists inside the abdomen, but also elbows and shoulders that replicate a surgeon's natural movement and create unprecedented dexterity and range of motion.
Right. So the basic idea is very, very small robot. You can thus put it into someone's abdomen or their stomach or wherever you need it with a very, very small incision rather than a large one that could take a lot of recovery time or stitches or something. As far as the XR goes, this robot, I'm not sure if they still show it on the website, but this robot can be controlled via a VR headset. So you kind of look around and you can kind of see inside, and then you can manipulate the controls in kind of a more intuitive way. And for a doctor, having a better user experience might provide better outcomes. So a very cool robot. It is very featureful. I will say, did you see the footage of the robot in the fake stomach? That kind of looks like it could be out of a horror movie to me. Okay, I don't want to think about this thing being inside of there doing work, but if it improves outcomes or lowers the cost of care, or if it brings care to people who otherwise would struggle to receive it, right, the remote operations, then that could be a very, very impactful thing. Okay, so one small incision, okay, 1.5 centimeters, that is very small. Very advanced technology, I'm not sure what that means. The surgeon is transported into the patient's body. Freedom of movement, so you can do all sorts of things, whatever you need to do in there to fix the situation. Inspired by humans, access, okay. And 360-degree visibility. I think it used to show a VR headset on here, but it doesn't currently. I think it still supports that. Maybe I should email them and ask. But in any case, a pretty cool robot. This is a bit beyond what we'll be able to do in 4 weeks because we don't necessarily have access to the hardware. They've got news. Here's something to think about. When you've got a startup website, you will all eventually be making your own startup website for that final project, okay? Why do you put a news section on here? Why do you write articles? Have you ever noticed that when you just do Googling and you're just Googling about a topic, sometimes you'll end up at an informative, reasonable quality article, but it's coming from like a startup. That's weird. Or like a company that is in the field. Do they just do this out of the goodness of their hearts? Do they divulge their secrets and their information just to help you? Well, partially, maybe. It depends who did it. But why would you want to do this if you are a serious startup? You want to start publishing articles. You don't want to give everything you know away, but you might spill some beans.
Lets you maybe collect more traffic and search results.
Bingo. Search results, okay? SEO, search engine optimization. If you start putting content out onto the internet, and in particular, if people start using it a lot, going to it a lot, reading it, linking to it, sending other people to it, that dramatically improves the authority of your website, right? You will be the website that comes up when someone searches for a medical XR robot, which could lead to incredible sales for you. Another thing that sometimes gets ignored is that putting information out also boosts your prestige quite a bit. So one of the reasons that Google does a lot of hackathon sponsorships, right, is because they want you to know about Google. They want you to know what cool things they're working on, what cool tech that they've got. They'll let you use the tech to play around with it. That leads to easier recruiting. That leads to easier deals in the future, right? People know who Google is. So for tiny teams that are looking for any sort of publicity and looking to make a name for themselves, to get some authority, this stuff matters. So sometimes you'll find like a lead engineer at like Airbnb will write an article about how they used, Kubernetes to do something, right? And then, that's useful for them. Anyway, often these kind of companies will have an investors tab. These kind of companies are often trying to either sell themselves to a bigger company or sometimes they have their own shares or stock that they're trying to get people interested in. Why does a company benefit if their stock price goes up? I know it's kind of a stereotypical thing that like, hey, stock price goes up, we get bonuses, right? Well, I'm not talking about the leadership. I'm talking about the company itself. Why does it like the stock to go up? Bigger number is more impressive, right? Well, there's that. But a company, when you buy a share of a company, the price, the value goes up because there's only a finite amount of shares. And if more people want it, the price goes up. If less people want it, the price goes down, supply and demand. If a company's share price goes up, that doesn't immediately help them, but it does in the near to medium to long-term future. What happens is a company can issue a new slate of shares. They can do an offering, I believe it's called. And that allows them to take in a huge sum of money to, for instance, open up a new research laboratory or launch a new product line. Now, if their stock price is very low and they do this offering, this round, they don't get very much money. They have to give away a ton of shares. That means everyone loses ownership and they don't get much for it. But if the company's stock price is very, very high, then they can sell only a small handful of shares and bring in a lot of resources to do things with. So you'll often find companies trying to have good relations with investors for that reason. That's one of the reasons anyway. If you want to learn more about this, you probably shouldn't learn it from me because I probably don't know what I'm talking about in any level of depth. You should go to our wonderful Center for Entrepreneurship where you can learn about some of this stuff and even some of the ways it goes wrong sometimes. Okay, oh yes, question.
Do they have anything about like the control scheme as far as the VR headset goes? Because like when
Yeah,
you
that's a
think
good
VR,
question.
You generally don't think fine motor control.
Yeah, that's definitely a good question. They had some footage. Did you see the footage? Oh, here's some executive team stuff. Did you see the footage? They had a snippet of a doctor using these this very kind of fine joystick, multiple of them. Let me see here. I don't think they have it on the front page, but in the video they definitely have it. Oh, you've got, the surgeon console. Yes. So when I last saw it, this screen was actually a VR headset, and they actually used these with a headset on. But you see right here, there are these little devices that look pretty fancy. And in the footage, we can see it being used. Okay. Dramatic music. Oh gosh, where was it though? Here we are. Okay, watch this quick snippet. Right? So you can move this around and it looks like you can also twist a joystick and also push it, the whole thing, and then also just the nubs. And so that's interesting. Yeah, so this probably provides finer or more control than your typical VR headset controller. But an interesting company, for sure. Any comments or questions on it? All right, very good. Okay, so we've got a few announcements today before we get into our main content. The big one, and this was something that was keeping me awake basically the entire weekend, a new course is coming very soon. Next semester, a new course on the topic of game dev. A very unique one is coming to campus. Might be of interest to you, especially if you are a bit artistically inclined, if you enjoy drawing or creating 3D stuff. This is the course where you learn Blender. This is the course where you learn how to create characters and environments and objects, and not only create them in 3D animation software, but to bring them into an engine and into life. In this course, you've downloaded objects from Sketchfab. But here's the question: who created them in the first place? How did they create them? And we want to do more than just bring them into our engine and just plop them there. How many of you, you haven't gotten to that part of P1 yet. Most of you are going to bring characters into your Project 1 in Unreal Engine, and they're going to basically look like this. The T-pose, right? Have you ever heard of the T-pose? Have any of you heard of the A-pose? Why do the T-pose and the A-pose exist? Do any of you know? Why do you typically build your geometry in this T-pose kind of formation? one of the reasons is that it makes it much easier to rig, to create an armature, to create a skeleton, an underlying piece of metadata. It's not a part of the model, right? It's not a visible part, but it's a way you organize the vertices and faces and edges of the model so that you can more easily deform all the things you need at once, like a robot. If you want to animate a character, you might have a character that has 10,000 or 10 million vertices, 3D points. Are you going to drag and drop and move around 10 million points? In the old days, in the PlayStation days, characters like Crash Bandicoot only had like a couple hundred vertices maybe. And so it was actually possible to move each little vertice, and you got really beautiful animations that way, but it was very time intensive, very laborious. For more complicated characters, you actually create an armature and you bind all of the nearby vertices to a bone on a skeleton. You can then animate the bone instead of the vertices, and you move them all, and it looks fantastic. It's super fast. It's great. An example is right here with Daisy, this character. And you can see that she has an armature that allowed for the dynamic action pose really, really quickly, okay? But this, of course, it's also about 3D printing and photogrammetry. You're going to be learning how to create models and characters and bring them into an environment like Unity and get them animating, get them running around, get them looking around, blinking, okay, dynamic hair physics, lava, flowing lava, and stuff like that. So this is all to say, our projects on campus, they don't look, they're great, they're well made, they're well designed, but they don't always look amazing. And this course is meant to address that, okay? Great for your portfolio if you want things to start looking a lot cooler. And if you want to understand just how do 3D assets work, how do 3D modeling programs work. Here's the course website, EECS298.com. This right here is a test bed. This is the final project everyone will eventually have. A 3D platformer that plays really well. It is actually, it is passive multiplayer. So if you go to EECS298 right now on your laptop, you'll see other players running around as well. You design the environments. You create the characters. This character is from Mario Kart 8, Peach, right? This is actually, I think, the first character you're going to rig up and animate. Why? What is very convenient about this character? What makes her animations particularly easy to start with? Yes?
The dress obscures the face.
Bingo. The running animation. The running animation is evil. Okay, it's so hard to do when you're first getting started animating. However, if you've got a longer dress that occludes it, then you can really just get a great running animation by just having the character go up and down. Take the root bone, animate it on the sine curve, you've got a great running animation, right? Just running around. It looks good, right? But this is what everyone's going to end up with. In their portfolio, a 3D platformer with characters made from the ground up by you, animated by you, with environments made by you. So this tree, for instance, I made this tree over here. This tree is a bit evil. The leaves are too small. But I made this in Blender in about 5 minutes, right? So this is the kind of thing you can't easily make in Unreal or in Unity, right? You have to make it in a 3D modeling program, and then you can bring it in, right? So anyway, bleep. And then you've got animations for all the different things, and you'll have multiple characters as well. Anyway, it's fun stuff. I'm going to stop droning on about it. If you have any questions about the course, let me know. 4 credits. I think it will be Flex Tech, probably. And if you need different kinds of credit, it's not going to be upper level CS or capstone, but you might be able to petition for different types of credit later. Anyway, yeah, it's going to be really fun. This stuff is super fun. Oh my gosh, I want to show you something real quick, okay? I'm making another character because I don't want just Peach here, right? Eventually, you have to animate harder characters, and you have to eventually make your own character from scratch. Has anyone heard of the character Rayman? Okay. Hold on a sec. Okay, let's go. I'm going to grab this for you real quick. Okay, share my work. Okay. Here we go. So, this is an idle animation, and I also did his jump up and jump down animation. But this is his idle animation that I did last night. What's really fun about Rayman is that he doesn't have any limbs, right? And so animating his different pieces is a little bit easier. Not as easy as Peach because you have to do the running animation, so you have to have the hands and the feet kind of moving in rhythm. But another cool thing about Rayman is that his geometry provides a mouth, right? So his mouth can be open when he's like looking around in wonder, or closed when he's bored, right? And there's a bone. The way I rigged him up is there's a bone that kind of goes out of his chin into his mouth, and there's a bone that goes up into his big nose as well. And you can adjust those bones to animate the mouth if you want him to look like he is talking, right? Anyway, super fun. It took me about 10 minutes, but I think it would quickly turn into more because it's just so enjoyable to do. Ubisoft is in big trouble right now, so pretty soon maybe Rayman will need some employment, and we will put him into our projects. Okay? All right, so let's keep going. Blah, 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 blah. Okay. Equipment lottery emails, I'm going to send them out tonight. Okay? I've been kind of slow on that, but I'm going to send them out tonight, let you know if you won, and then we can probably pick those things up probably Thursday or Friday maybe. I'll be back in town and I can drop them off. But please look for that email, okay? Project 1. You are a few days into this project, but because of the schedule, because of the MLK Day, we didn't really get a chance to talk about it. So let's do that. You haven't seen this briefing, have you? Okay. Project 1, what is it? Well, if you remember the very first day of class, we talked about what these projects are going to be and what their purpose is. This is going to be a recreation of a location on campus, all right? This is the CSE simulator. And your mission is going to be to create an immersive space that doesn't just kind of look authentic, but it also behaves authentically. Remember, from our game engine talk, it might be even more important, all right? If you want to create realism, it doesn't always matter the aesthetics. What really matters is the interactivity, okay? So when you go and flick the light switch, do the lights turn on and off, okay? Do you hear it? Do you see it, right? And so we are going to build CSE Simulator. And have any of you ever heard of this game right here? It's called Job Simulator. Any ever heard of that? So let me get this in Google real quick so that I can actually maximize it. You'll see it. It'll look good. But Job Simulator is a game that is kind of funny. It's humorous. It is a game whose premise is this. It is the year like 3000. Robots are the only things left, okay? But robots care about history too. And so the robots have come together and built an exhibit to remind all the robots of the world what humans used to do in offices, okay? And so they mess everything up, right? But I want you to watch this trailer right here. It's a fantastic trailer. I want you to think about one interesting question. I know it looks cartoony, but how realistic is what you're seeing? Let's take a look.
Hello, human. Welcome to an accurate simulation of this work. Time to jump. This looks like it'll taste interesting. Delicious. Oh no, the boss bot is coming. Hey, you were doing jump. Looks like I've got some money to blow. Shred everything for legal reasons.
Today's not your lucky day, pal. Open that safe.
Holy smokes, this is way too hot. You've been doing a really good job lately. I think it's about time you got a promotion.
Hooray! It's 5 o'clock.
Woohoo! It's time to go home! Yeah, I'm gonna have to ask you to come in on Saturday.
Okay, right? So this game, this project, this experience is a very cartoony art style. They are trying to recreate a space, but what's more, they're trying to recreate the interactions within it and the vibe. When you see a keyboard, okay, when you're looking at the footage here, and you see a keyboard of an office worker just kind of playing, I think it was Flappy Bird, right? And the 0 and the 1, right? How realistic does this feel to you? Does it look realistic? Is this how it actually is? No, right? Keyboards are more complicated than that. No, you're not always playing Flappy Bird, right? No, passwords are actually almost never this bad, right? Password 101. However, it might not look very realistic, but does it feel realistic? Are the vibes right? Because I think many people would say that, yeah, people are terrible at passwords and things are super insecure. The things we do on our computer for much of the day at many of these kinds of jobs do feel a bit mundane, a bit unimportant, right? Sometimes it feels like we're just not doing a whole lot with our keyboard, right? There's just not a whole lot going on. Or maybe the software is so complicated, we need to have it simplified. You see, there is one sense of realism where you're just trying to accurately recreate everything pristinely. But there's another where you're not trying for accuracy of looks, you're trying for accuracy of vibes, okay? And that's something I would ask you to think about. During this Project 1, you will recreate a computer science laboratory. You will be adding computer science students into that laboratory. You will get to choose what they do and what they say, okay? You'll get to choose how things look. And so, what I want you to think about right now, ask yourself right now, do you have any opinions about the CSE experience? What is it actually like? What does it feel like? I don't care so much what it looks like, okay? But what does it feel like to be a CSE student in 2025? That's what I think you should put into your P1. Okay, that's going to be the most accurate thing you could produce. And when people look back at these in the future, that's the vibe they're going to get. Okay, what was it like to be a CSE student in 2025? Was it super stressful? We've had students who introduced the custom feature of ordering pizza, ordering energy drinks, and your screen goes crazy when you drink the energy drink, right? I've got an energy drink right over there on that table. I don't think I should have it in here, but I do. Maybe I should make a CSE simulator that's from the faculty perspective, going home and creating courses and all that good stuff. All right, so anyway, what are the actual logistics of this project, okay? CSE simulator, you'll be recreating this space as authentically as you can. And I mean vibes, not necessarily aesthetics, okay? This is what you will be starting with this week. Some of you might have already begun with this. Do you know what this is usually called right here? You've got kind of the layout of a laboratory, right? You've got a clear space for some desks. You've got a little door over there, some trash cans in the corner. This is called a gray boxing or a boxing out, okay, of the space. This is usually how you start when you're creating an environment. You start by creating it super low detail, and then you go in and you progressively add more details piece by piece. So, for instance, you're going in and adding windows in that image right there, okay? Eventually, you're going to get to the point where you switch to interactivity. So what you'll be doing is you will be going through and you'll be creating these components, these blueprint components. You'll be attaching them onto actors in your scene, and that will give them behavior, okay? That will allow you to do things, all right? So here's an example. Right here, I have a blueprint. It is a blueprint component. It's called AF Toggle Actors. What on earth does AF mean? AFF. What is that? Have you ever heard of an affordance? An affordance, we're going to talk about that more in just a sec, but an affordance is a component. It's a blueprint that allows you to do something. It affords you the ability to do something. In this case, what is the thing we're doing? Toggling actors. Okay, so it's toggling actors on and off when you interact with the object. Which actors? Well, if you look right down here, we have configured 3 actors, 3 red apples. So when we click on the trash can, which has this component, these little actors will turn off and on. That's why the apples disappear. Same thing with the light switch, except it's lights turning off and on, okay? So you will get to create this space, and you'll get to choose who's in it. Okay, in this case, we got a bunch of penguins serving as our CSE students. If you walk up to them and click on them, they will talk to you, and they will say little speech bubbles will show up, and you can go through a little conversation with them. Over here, we got Voldemort and Harry Potter. We have a whiteboard that you can draw on and leave messages on. Okay, that is one object, one actor, and one interaction that you'll have to do. The whiteboard is kind of a tough interaction. You don't have to do it this week, okay? That's next week, all right? Here, right, you've got a penguin asking you red or blue, okay? We watched The Matrix. Did we watch a film yet? We haven't. Okay, we're going to watch The Matrix soon. Very good film. And this is a custom mechanic, a custom interaction that is done in the final week of the project. This team decided to make a matrix simulation. So you take the red pill by clicking on that part of the poster, you end up discovering that computer science was all the matrix all along, and you can thus fly around the city, the dystopian city, and you've got your freedom back, okay? You can do whatever you want. The team was very ambitious. Some teams have said, we're going to introduce an energy drink mechanic, where you grab the energy drink and you drink it, and it affects the screen or affects your movement. Other people have done really wild things. Sometimes the teams decide, hey, sometimes being a computer science student is very scary. It's very tense. And so let's make a horror game. And so, I think last semester someone fell into the back rooms, if you know what the back rooms are. Exploring CSE, you fall into the back rooms and there's a monster that chases you through there, and it's a good time. What's the point of all this? Well, we're going to see, if we haven't already, that the ability to create an immersive environment in VR, one that's really interactive, is a kind of a key part of creating XR content in the first place, okay? You can see with products like Titanic VR, right, Everest VR, we need to get good at creating environments. We need to get good at creating interactive elements. Now, 298, the new EECS 298 course, is all about producing these art assets ourselves. In this P1, you're almost certainly going to go out and find these things, bring them into your project, and that's going to work as well, okay? But here's the takeaway. Immersive interactive environments are basically step number one, at the very core of applications in field trips, exercise, visualizations, training programs, stuff like that, okay? In fact, a lot of students who take this course then go on to work at various VR and AR labs around campus, and that's a really important skill. Those VR and AR labs usually have you building a nuclear reactor, right? A virtual nuclear reactor for training purposes, or recreating the University of Michigan DIAG, okay, for some visualization purpose. So anyway, it's important stuff, and we got to get good at it. So a couple days ago, the project started, all right? These are our important kind of days here on the top. You can break this project down into three main categories, okay? We got engineering stuff to do, we've got design stuff to do, and we have some business and production assignments as well, okay? Your major concern right now, this week, until Monday, is P1 milestone. Has anyone taken a look at P1 milestone yet? It's kind of a big assignment. So let me go ahead and show it to you right now, all right? This is a pretty big assignment, and you can get to it right here, P1 milestone. And as you read through this, you're going to find that one of your tasks is to make progress. Okay, what does that mean? Well, all of you have this big spreadsheet available. And each row of this spreadsheet is another task, okay? These tasks all are worth points, story points, and you want to do as many as you can, especially the ones marked 3, okay? Now, these tasks, they come in different shapes and sizes. So here's a good one. One of your tasks is going to be to create some ceiling lights, okay? Well, you're just going to go ahead, you're going to go into Unreal, you're going to spawn in some lights, move them around the room, right? Make them as accurate as you please. And that's the end of the task. If you are ever needing hints on any of this stuff, there's a hint column in column D. In column C, there's kind of a deeper detailed breakdown of what we're looking for and what we want you to do, okay? So for instance, one of your major tasks this week is to block out the area structure, okay? The description says, hey, you don't need to be super accurate, just be a rough approximation, okay? We want you to block things out. And we also have some links that might help you out, right? So this is what blocking out looks like in Unreal Engine. That's the kind of thing we want you to do, okay? Get started at doing that. There are, in the hints column, some examples, okay? Some example code, right? For instance, this was my blocking out of the project back when we first launched the course. And some more videos. One big challenge you'll face is, oops, I accidentally made everything too big. And you go into your headset and you're like, wow, I feel like a tiny little child in this environment. Yeah, you don't want to make that mistake. So something I recommend is, don't do too much work without testing. All right? Test, test, test. That way things will be the right scale when you're ready. But you'll be doing things like you'll add some desktop computers in. You'll add some garbage cans and some pieces of garbage to your environment, a door. You'll add some background audio that plays to make you feel like you're in that environment, okay? All of these white tasks in here, the rows that are white, those are due for P1 milestone. Column F tells you which assignment do you need to have these tasks ready for. And you can see that P1 milestone is due on Monday. P1 Alpha, though, is not due until the 3rd, and P1 Gold is due on the 12th, all right? So you can look through. Here is our P1 Alpha. You don't have to do these yet. These are harder, okay? Down here, you'll find an interactions category with more tasks. So you'll have to build an interaction system. Now, we're going to build that today together, okay? We're going to get to that very soon. You'll need to have a light switch that toggles lights off and on. You'll have to have that done by Monday. We're going to do that today. You'll have to get trash working. You'll have to get an exit door interaction working, where when you point at and click on the exit door, it turns off the game, okay, and ends. Eventually, you'll have to do trickier ones like fire alarm. That's coming next week. And you'll have to do copy machine, the whiteboard, okay? And you've got lots and lots of hints on what kind of nodes you might want to use and how you might want to think about this, okay? So don't worry too much. At the very end, you've got your custom tasks. So you've got your custom object, okay? Red pill for the matrix. Oh, here's the energy drink task. Very simple one. You drink something and your vision is now flickery. It's gray. You're freaking out for a little bit. And I think eventually your vision comes back to normal. Yeah. You eat something and your vision goes back to normal. Okay. So not a super complex task. You can make those gold, final tasks as simple or as complex as you really want. We're not super strict on any of that. You can do a hidden beer pong mini game. Okay. You can look at these examples down here to get a feel for what we're looking for. All right. Does anyone have any questions on this first P1 milestone? Okay, let's keep going. We're going to do a lot of this today, all right, just a reminder. So P1 milestone will turn into P1 alpha the following week. You'll have a week to do more tasks and more complex tasks, okay? Now, here's something that everyone forgets, but it makes your project way easier if you remember it. These tasks don't need to be perfectly finished. They don't need to be entirely complete. As long as you have put in some obvious, clear, visible effort on a task, you'll get full points for that task until P1 Gold. Okay, that's when we want you to finish the entire project, finish all the tasks, bug-free, looks good. That's what we want, okay? So my advice when you're doing those tasks, just get a quick and dirty rough draft in, and then you can come back later and fix things up, all right? So anyway, you'll have 1 week to work on P1 Gold. During this entire time, you also have the P1 Project Management assignment. This is a project management assignment, and the spec has all the information you need. But when you go and look at the spec, it will tell you how to set up your Jira. It'll tell you how to break tasks down. It'll give you hints on how to work on the project with a teammate. And so please read through that and start using your Jira software as soon as you can, okay? it'll be good training for the final project where you have more people, more tasks, and all that stuff. The final week here, about actually final 5 days, you're going to do a post-mortem, okay? This is a reflection essay, but essay is a scary word. It's not an essay, okay? You're basically just filling in some questions, and you're kind of reflecting on the project. What went right? What went wrong? What can you do differently next time to get a really nice positive result, okay? So that's the project, all right? It is not a super easy project, but it's also not super heavy either. If you start your assignments early, and if you watch these videos, the recordings, you're going to knock these out pretty quickly, okay? Use your hints. They'll help you move much faster. You've got teams of 2. Now, I think some of you had to have teams of 3 due to some, we had an odd number of people in the course. But teams of 2, for the most part, Unreal Engine, okay? The way you're going to submit and get points in this project is every week you're going to take video footage, just like for tutorial assignments and exploration assignments, and you're going to submit videos to Canvas that show those tasks being not entirely complete, but a good rough draft state, okay? And you'll get points when you do that. The final deliverable is quite big. You will do another video showing off every task, but you'll also submit your source code, and you'll also add it to your portfolio website. How many of you have a portfolio website? Okay, if you don't, this course will provide a good opportunity to create a portfolio website. Really important. It can help you get jobs in the industry, in any industry, really. So you'll have that by the end of this project, okay? All right. So does anyone have any questions? If not, I think it's time to do some programming together, okay? So let's go ahead and get to that. What I want to show you, what I'd like to show you is something called an affordance-based interaction architecture, or you can just call it affordance selection architecture. So let's talk a little bit about VR and interactions in VR in general, all right? Humans are kind of built to interact with each other, aren't they? So from the moment that a child is born, they have the cry technique, right? And it's kind of funny to think about, okay? Why do we think about how a baby interacts with the world? Well, we need to think about how children and babies and how humans interact with the world because we need to recreate some of that in VR, and our interface is limited, okay? One interesting thing about the cry technique, okay, is that you can tell someone that you want something, right? But can you tell anyone what you want? Can a baby do that? A baby is kind of like a binary alarm. Like things are either okay or they're not okay. You won't get any more information than that, okay? You have to kind of figure it out or guess or just wait until, hopefully it goes away and is dealt with. However, as the baby gets older, their interaction techniques become more evolved, okay? They become more informationful, right? Eventually, the baby can do what? Any idea? They go from just crying and saying, I need help, to saying a little bit more. Eventually, they gain the ability to point. Have you ever noticed that? They can cry, and they probably will still cry, but they also will reach for something, or they'll point at something, okay? The human is gaining more and more mature interaction techniques, okay? More information can be imparted now, okay? Eventually, the kid grows up, okay, and they can actually talk, okay? They can just richly interact with humans around them, okay? We go from I want something to I want something and it's that thing to like full-on writing essays to complain in very intricate ways about what we want and why we didn't get it. And no, I want this, but I don't want it like that. I want it a special way. Okay, whatever, right? We are built for interaction, okay? That is the thing to take away here. Human-to-human interactions are extremely subtle, and they're also very deep. They can convey a lot of information very quickly, okay? The facial expressions, okay? The way that the sense of touch, okay? the way that you decide to, look angry, right? Or look disgusted, right? Body language, okay? So a really fun example is like, if you look at me up here, if I walk up to you someday, you're studying in the library, and I walk up to you and I'm like, right? It's a pretty friendly thing, right? It's going to be a friendly conversation. I probably have nice things to say or something, like that. If you see me coming up and I'm like, right? That's a very different vibe, okay? Very different vibe. In fact, just the way that you orient your shoulders against someone has a different vibe, right? If it's like kind of off the center, it's like, a little bit more peaceful and relaxed, okay, but more casual. Right? Way crazier, spooky, okay? Don't do that to people unless you want to try and get something across. But this is not super important, okay? Because humans are boring in this class. We don't care about humans so much. Well, we do, actually. But what we really care about are human-computer interactions. And the School of Information is all about this, all right? We have a lot of great research laboratories, Professor Niebling's laboratory on campus. This is all about how do we get software and robots to interact with humans, to express information quickly and deeply with humans, okay? This is Simone Geertz, who has a lot of fun robots that do goofy things, okay? This is much harder, okay? How do you, in software or in the language of robotics, communicate the things you need to? And I really love this one right at the end with the Roomba with the knife. Be careful, okay? It's not in a good mood. If you think about ways we currently do this, do any of you remember when you learned command prompt or terminal for the first time? Okay, I remember I got to college. I'd never used Linux before college. I get to college, undergraduate, I'm in EECS 280, and I'm like, what? Where do I click? Okay, and you don't click, right? You need to type stuff. I need to type stuff, right? What do I need to type? Okay, you learn about commands like ls. You may learn about commands like cd. Okay, you learn how to run a program, the slash, right? The problem, though, is that this right here, this command prompt is super good and fast, but it requires a human that has been specialized. It requires specialized training. It is not intuitive. If you show this to a random person on the street, they'll think you're actively hacking someone right then, okay? Because that's what you see in the films, the movies, right? You see something like this and just pouring down the screen. Now, there's another kind of modern way to interface with robotics and software. This is voice, okay? Voice commands, right? Natural language processing, okay? Alexa, play some study music for me, okay? And it will go do it. This is moderately fast, but it's also kind of clumsy, okay? How many of you have accidentally had Alexa or GPT even mishear something you said? It happens all the time. Okay, often I'll be in my car and you can't, text or do anything while driving, or you can't Google search while driving, but I'll ask GPT something and it will completely mishear me. Okay, and it's very, very annoying. Has anyone ever heard of the Kinect, the Microsoft Kinect? This is a full body way of interacting with software. Okay, this is a camera that watches your posing and then basically constructs a skeleton, an armature, which we were just talking about. It constructs a dynamic armature as you move around. And the software can take that armature, look at where the bones are, and move a character to match you. Or it can say, oh, the player's hand is over here, so they want to select this button, so let's go to the main menu, right? It's very accessible, super fun, but it's laggy. You can actually see the lag. It's like a second of lag in the GIF. It's very, very clumsy, okay? Extremely clumsy. In fact, there were some games that came out for the Kinect that were completely unplayable, broken, borderline, okay? And so Kinect got a very bad reputation for the quality of its software, okay? One of the best and most prolific means of interaction is actually the gamepad, the game controller. Almost every company in the game space, platform space, has their own controller, and they almost always look like this. Okay, it is very optimized. It's very fast. It is a bit limited, though, and it has a specialized human need, just like the command prompt. Have any of you ever tried to play video games with an older relative maybe who's never played them. It's almost always a disaster, right? They look at the controller, they're instantly super confused, and their head is constantly going up and down, right? When you watch someone who's very comfortable playing games, they don't do that. Their attention is focused on the screen. Their hands know the language of the controller, okay? What's more, game genres have standardization to certain buttons, okay? You know, if I show you a controller, which button will probably make you jump, wahoo, in a 3D platformer, okay? And new players just don't have that kind of knowledge, all right? So what are we going to do here? Well, these two are really good, okay? What if we could make the controller a little bit easier, a little bit more intuitive, okay? We're going to take a controller, but we're going to design it with fewer buttons. How many buttons do you see on here? It's a little bit far away, but I count one big one, a small one, 2, 3, and then there's one on the side that's visible, so 4, compared to the like 20 plus that are actually on these controllers. It's also gesture-based. So these controllers for VR have the ability to track their movement, their motion, where they are in 3D space. All right? And this is really a big deal because this allows us to tap into that childlike interaction of simply point at the thing that you want and you get it. Okay? That's kind of why these are designed that way. All right? Not to confuse people, but just to do and be the way that humans are in real life. All right. So in this first project, this is how you will interact with the world. Okay. You will point at the objects you want to interact with. Hopefully they're close by. And you see this trigger button on the back right here. This is how we emulate you kind of sticking your finger out to choose that thing. Okay. So you're going to point at something, you click, and you've got it. Okay. We're going to do something when you click on an actor, all right? So the first phase of our development today and in your project is going to be the development of what we call a selection system. It sounds incredibly simple, right? We just need to know what the player wants. But actually, this is terrifyingly difficult. It's a very tricky challenge. The player can't really just tell us. And so we need to develop a way to line trace out from the user's hand out into the environment, and we have to kind of keep track. Okay, is the user pointing at the trash can? Is the user pointing at that wall? Well, we don't care about the wall. If they're pointing at the light switch, we need to take note of that fact, okay? Because if they're pointing at the light switch and then they click the trigger, we need to do some stuff, okay? So here's the architecture we're going to use. We're going to introduce the line trace, which you already know about from your Exploration VR. Okay, funny how that works. We're going to have a variable. We're going to have a variable that is called current hovered actor. What does that mean? Well, this is always going to tell us. It's always going to store the actor that we're currently pointing at, so we can use that later. Okay, you can see that this variable is of type actor, so it's going to work just perfectly for us. It's also not visible, right? The eye over here is closed. So it's not something that we can just edit willy-nilly in the editor by dragging stuff, okay? This variable is going to be filled by some logic coming from the line trace. Whatever the line trace hits, we're going to put it into that variable, okay? Now, the last thing we need is trigger press detection. We need a way to detect that trigger button on the end of the controller has been pressed, okay? Because eventually we will need to do some interesting things, some different things, depending on what actor we clicked on, okay? And so we should go ahead and get to that, all right? I think the name of this action, this event, has actually changed. It's actually a big pain in the butt, okay? But let's go ahead and do that. And so a reminder, I'm going to explain what we're doing today, and I'm going to walk you through it a bit, but you can always review this lecture recording, okay? You can review the lecture recording, and you can just do and follow along with what we do, okay? So right now, I need to make sure this is working at all. So let's go ahead and get into our VR headset. I'm going to get this thing set up, okay? Hopefully it works all right for us today. These headsets are getting a little bit old. I like them a lot, but they are a little bit of a pain. All right. Okay. And let's go ahead and get this plugged in. Okay, I'm going to plug the HDMI in. I'm going to plug the USB in. Okay, there you go. I've got cables all over my laptop. All right, this is the leading edge XR experience. Okay. Hopefully our live stream is still doing okay. Still doing okay? Yeah. Oh, I look ridiculous. Okay. Let's see if I can run this. So VR preview. Okay, and I'm going in. All right, and do my hands appear? Do my controllers work? Maybe, maybe not. We'll see. Okay, and I got 2 hands. Rock and roll. Do you remember our garlic over there? Remember first day we did the garlic, right? Okay, so what we want to do here is we want to do a line trace. All right, we want to do a line trace, so where should we do that? Well, one place we can do that is in the VR pawn. If you think about where most of our player logic currently resides, the warping, the teleporting around, the turning, it's all in that VR pawn blueprint. If I click on content and then search for VR pawn, I'll find our blueprint right there. This is what spawns in to our world, okay? This is the actor that's going to represent the player. When you look at this VR pawn, when you dive into its guts, you can find a lot of stuff, all right? And we don't need most of it, okay? We do not need most of this. In fact, we're going to ignore most of it, okay? By the way, a quick story. When I first joined the Sims 4 team, the game had been in development for about 4 to 5 years at that point. It was a code base of several million lines of code. I think 3 or 4 million lines of code. How do you learn 3 to 4 million lines of code? Anyone know? You don't. You're not going to learn 3 to 4 million lines of code. Are you crazy? There's not enough time for that, okay? And also, it's not relevant to you. What you do is you pinpoint. You go in like a surgeon, and you try and find the things that are relevant to you and your objectives, okay? You ignore everything else. So that's what we're going to do. We're going to ignore this code. It looks like it might be teleporting code. I don't care about that right now. Snapping, it's a great feature, but we don't care about it. Teleporting, grab left, grab right. You know what I really want? I want to run a line trace every single frame. So what should I do? Anyone have any ideas? I need to do something every single frame. If only there was an event for like updating or like every tick of our game. Has anyone heard of anything like that? What's it called? Don't be nervous, Justin. Event tick, yeah. Hey, that's exactly what we want, right? Event tick. So I'm going to go ahead and right-click and then go event tick, and I'm going to pull this out here. I want to make sure it's working, okay? Always verify things are working the way you expect. I'm going to print tick, okay? I'm going to print tick every frame, and it's going to show up and go crazy. All right, let's go ahead and make sure that happens. Compile. You tell me if the text shows up, because I can't see in the headset. All right? You see ticking at all?
Yeah.
Oh, it's just taken over the left side of the screen. Okay, that's good news. It means it's working the way we expect, but we don't want to print messages. What do we want to actually do? I want to do some line tracing, okay? So, but you know what? I want this to be really organized. So here's what I want to do first, okay? I'm going to create a new function. I'm going to go over to my little functions area over here. I'm going to click plus, and I'm going to call this, let's call this determine current hovered actor, okay? I'm going to determine the current hovered actor, and here's my function, okay? We're inside the function now, okay? You can tell because the tab up here. I can go back to our main event graph, and I can see everything else. But I really want to call that function. So I'm going to drag that function right out here. It's a new node. We just created a new node just like that. So every frame we're going to run this function, I can double click on it to go inside of it. That's going to determine the current hovered actor. Well, we don't have any place to store the current hovered actor, so the next thing I'm going to do is go to variables. I'm going to create a new variable. I'm going to call this current hovered actor. It's currently of type Boolean, which is not what we want. We really want a type of actor, because it's supposed to be an actor, right? I got to look through here and find that actor data type. Where is it? Here it is, actor. Okay, I'm going to go to object reference, and now I've got my current actor. I can bring it in here and use it if I want to. I can set it, I can get it, whatever I want to do. Okay, we want to do a line trace. So how do we do this? Well, let's go ahead and pull our little line of execution out here, and I'm going to search for line trace. We get all of these cool little functions, but I think the one we probably want is line trace by channel, okay? And if you look at this, this is going to do a line trace between 2 points, start and end. And we can manipulate that. We can change, what kind of lines we want to have. How about we do a little test, okay? I want to do a line trace that is from 000 to 500 meters or units up, okay? Like that. So I'm going to put 500 in there. I want to be able to see this line trace. So let's go ahead and look through here. Draw time, trace complex actor, debug draw type. Here we go. We want the draw debug type to be on so we can see the line trace. So let's go to for one frame. I believe this is going to be a red line, and when it hits something, it'll turn green. Let's see if we can find that line trace, okay? Let's see what happens. Okay, do you see it? Okay, so we've got a green line trace. Okay, it's going up into the air. That must be the origin of our environment right there, 0, 0, 0, 0, 0. And that is 0, 0, 500. So 500 units in the air. It's not as much as you'd think. Our units are very small in Unreal. In Unity, the units are gigantic. Okay, so that'd be way up there in Unity. So that's good stuff. Okay, what do we want to do now? Well, I want the line trace. I want the line trace to come out of my left hand. Okay, I don't want it to just go from one arbitrary point to another. I want to actually have it come out of my hand. So let's do that. How do we get the location of the player's hand? Well, it's kind of tough, but fortunately the VR pawn has everything we need. If you go to viewport up here, if you go to viewport and you actually look at the components that you have, okay, this is actually what the VR pawn looks like. Okay, you can actually see the headset. Do you see the headset right in here? Like this, yeah. You can see the headset right in here that makes up the VR pawn. And you can also see the controllers and the hands in here that make up the VR pawn as well. No, that's not it. Let's see here. Where is that hand? Here's the right hand, but I want the left hand. Where's the left hand? Oh, there it is. Okay. Here is your left hand right there. So what I want to do is I want to grab that left hand and get its location. Let's go back to the event graph, and I'm just going to grab that left hand and drag it right in, okay? So we can see here that we've got a hand left of type XR object reference. I'm not entirely sure what that is. Oh, actually, I don't even want it there. I want it inside this function. So I'll copy and paste it in. We got that left hand. And now I got to get its location somehow. All right, so hopefully I can get it. Let's see, location, world offset, get world location. That's looking really good. Get world location. You can see that it's a little yellow output little orb right here. That means it feeds perfectly into our little start value. You see that? So now that we've plugged that in, we expect the line trace to go from our hand to someplace else. I think you did maybe a lot of this in tutorial VR, but we'll just go over it once more just to make sure it's feeling good, okay? Okay, I've got my hands over here, and I expect to see that line kind of coming out of my hand. Do you see it? Yeah, so we got that red line coming out of my left hand and is going kind of up into the air. Okay, is it really laggy to you? Or is it pretty smooth? It's a little bit laggy. Yeah, it's really laggy because I'm running this on my laptop and I'm also streaming at the same time. So that's really hard for it. But anyway, it's working. So now what we need to do is a little bit of math. Okay, we want our end position to be basically extended out from this position. So we'll take this position and we need to add to it. Okay, how much do we need to add? Well, we need to get the forward vector that kind of comes out of our hand. So let's go ahead and grab hand left again. Let's try and get, I think, get forward vector. We might need a different vector. Which one are we going to need here? Left hand. It looks to me like we might want the up vector, which is that green vector right there. Okay? Actually, I think it is. We'll just experiment, though, and see what happens. Okay? So we got the forward vector, and now we need to add or multiply this forward vector to extend things out. So let's multiply. Okay, let's multiply by a float value. So make float literal. Okay, and so now we can take this, plug it in. We now have a nice long directional vector. We're adding it to our hand's position, and that's going to give us our final line trace location. I'm going to make this really big, like really big. 50,000, okay, so we can point at anything from across the planet. Okay, now I want to add these two right here. I want to add these two vectors and plug it into our endpoint, okay? So this is kind of our final calculation here. It's a little bit hairy, especially if you're not used to 3D math. But hopefully, we will have a line kind of coming out the end of our left hand here, okay? Oh, well, it's coming out the bottom of our hand, okay? So that's something, but that's not what we want. So instead of using the forward vector right here, let's use something like, I don't know, get up vector, okay? Maybe the up vector is the one we want. We can also try right vector if this doesn't work out. Okay, what do we got? Oh, it's coming out the back. Okay, so that's not quite what we want, I don't think. Let's try the right vector. Okay. Okay, here we go. Do you remember what we did in tutorial VR? Does anyone remember? Okay, hey, that's perfect, okay? So it looks like the right vector is the one that kind of comes out of the hand. That's really the one that we want, okay? Well, very good. Is teleporting working? Let me see here. Yep, teleporting works, and with the other hand, we can go and we can select stuff, okay? Now, we've got this raycast, this line trace that is flying out there, but we want to know what we hit. So how do we know this? Well, this line trace by channel node has this little blue node that comes out, and this is going to tell us basically what did we hit, okay? It has type hit, so this is not an actor. It just looks like one. What we need to do is do break hit result. Now we can get all sorts of information about what we actually hit with our line trace heading through the scene, okay? So the one we probably want is the hit actor. What actor do we just bump into? So here's what I'm going to do, okay? Here's what I'm going to do. I'm going to print the name. Let's see here. Actually, you know what I'm going to do first? Let's go and take that variable, okay? Current hovered actor. And I want to set that variable, okay? I'm going to set that current hovered actor variable to the actor that I hit. All right, and I'm also going to do a little bit more just for testing. I'm going to print. I'm going to print a message. Print string, and I want to print that actor. Okay, we're going to print the actor's display name. So hopefully, when we point at a block, it'll say, "Hey, this is a block." If we point at the garlic, it'll say, "Hey, this is garlic." Right? So let's find out. Now you're going to have to tell me what it says. So I'm going to point at the garlic over there. What does it say? BP Garlic. Good. I'm going to point at the cube. What does it say? Great. And the sphere? Okay, excellent. So everyone, like, understand what we got here. I can point at the pistol. It'll say pistol, okay? Understand what we have here. We now have the ability to know at any moment what the player is pointing at. And that's really powerful. We can do a lot of things with that, okay? But the last thing that I want to do is I don't want to print. I don't want to print every frame. What I want to do is I want to go back and I want to print when I press the trigger, okay? We need some way to know when the user has pressed the trigger. Now, this is actually a bit tricky, and you might need to follow my lecture notes on this one. But in recent versions of Unreal Engine, you actually have to go in and make some configuration changes. We need to find IA hand index curl left, okay? This is almost what we need. Let's go, what do we have? IA hand thumbs up, IA hand point left, index curl left. Bingo, this is really the one we want, okay? I'm actually going to detach it. I'm going to bring it down here, okay? This is almost perfect, but we really want an event that is only going to trigger when you press that trigger once, okay? It's not going to infinitely trigger. It's not going to do any weird stuff. If you test it out, it definitely does some weird stuff by default. So we're going to go in and make some changes. Change the value type to bool. So we're going to go search for this little input configuration file. So we'll go to content. I'm going to search for this. There it is. I double click it. And I'm going to change the value type from an axis to a digital bool. Okay? And it affected one blueprint. Okay, remove that stuff, the animation nodes, move to the bottom, use completed node for execution. So this is basically going to give us a nice crisp detection of when the trigger is pressed and no other, funny business, all right? So we'll use the completed node coming out of here. And what I want to do is I want to print that string message, but I want to print the name of our current hovered actor, okay? We'll go ahead and we'll plug it in just like this. Bingo. It already automatically gets the display name. And hopefully, when I do this test, we won't see a bunch of text going down the screen. We'll only see a few of them for every time I press the trigger, okay? So you're going to have to help me out and tell me if this is working properly. So if you're far away, by the way, and can't see very well, let me know. I'm going to shoot this cube over here. Ready? I'm going to press it. 3, 2, 1. 1, 2, 3, 4, 5. Okay, what do you see? Okay, garlic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, did it work? All right, rock and roll. Okay, we are set up with the basics. Now, a lot of this might feel a bit boring, but it's really important we get this right at the start of the project. And this will make our lives much easier. So we've completed our objectives, actually. If you look at the selection system, we have all these things. A line trace, we've got a wonderful variable, current hovered actor, that helps us know what we're currently pointing at. And we've got this trigger detection, right? So when we press the trigger, we know that happened, and we can do cool things. So what else do we need to do? Well, a couple things, all right? We need to introduce now the concept of affordances. We have the ability to select something, boom, boom, boom. But now, if we select the garbage can, we want to do something. But if we select the light switch, we want to do something else. So how are we going to do that? All right, that seems like a bit of a tricky thing. Well, we're going to make a really wonderful architecture here that makes all of this really nice and easy, okay? Especially if you have some knowledge of game engines already. When I was working on The Sims, one of the ways that you took an object like a slip and slide, or an object like a stereo, you can see in the corner right there, or a restroom, you would take the object, the actor, it's called, and you would put a component onto it. Okay, that was called an affordance. So, for instance, for the stereo, it would have an affordance listen, because you can listen to the stereo, right? But you can also listen to the TV. So maybe the TV will have the same affordance on it, okay? And so the idea of an affordance is that it's some purpose or usage that an object can have, okay? And so we need to create those. If you look at one of my, this is my current indie game I'm making. It is kind of college-themed survival horror game. And if you look at the objects in this game, like a piece of paper, right? If you click on this piece of paper in Unity, you'll see that we have the affordance document, okay? The document affordance. What does that mean? Well, it means you can interact with this piece of paper, and when you do so, you'll get to read a document, okay? Makes sense. It is, after all, a piece of paper. If you look at this apple right here on this plate, it's a little bit hard to see, but this has the affordance collect, so the collect affordance. That allows you to interact with the object and put it into your inventory for later use, okay? This door right here has the travel affordance. So if you interact with the door, it will go and trigger the affordance, and the affordance will actually warp you and take you to a new location, all right? So it's kind of cool. What we're going to do is we're going to create an exit door, all right? And what it's going to do is it's going to have two affordances. One affordance that prints a message to the screen. And it's going to have a second affordance that quits the game. So two components, both of them affordances. By the way, that's just a conceptual thing. They're going to be blueprints, blueprint components, but they're going to derive from the parent class affordance. I'll show you that in just a moment. And it's going to look like this. Well, we're going to add these two components right here, okay? And we're going to customize them, and we're going to go and we're going to try and implement them, okay? So a quick thing to think about. You know how we have event begin play and event tick? These are really nice, right? These just run at certain moments in our game when certain things happen. An update happens or the game begins, all right? Well, what if we had a third event, okay, called interact? Wouldn't that be great? It'd be fantastic, right? We could just use this event and, whenever someone points at our actor and clicks on it, we run, right? We can do whatever logic we want. The problem that we currently face is that this does not exist by default, okay? The interact event doesn't exist. We can't use it. But what we can do is we can go make it exist, okay? And when you're doing this, you're really becoming less of a programmer and more of a senior architect, okay? You are creating new tools that your team members can use, all right? Powerful new tools. So we need a way to create this interact event right here, and we're going to do it, all right? If it did exist, we could easily implement that exit door by just using the interaction event and using the quit game node. Easy, no sweat, all right? For that other affordance, right, we could just print a string, okay? And then that would be finished in just a couple nodes. It would be great. So how do we create this new interaction event? What we're really doing is we're creating another life cycle function. So another function that allows us to run logic at a different time in the program's execution. In this case, not when the program begins, not when the program updates 60 times a second, but when the actor gets clicked on. Okay? We're going to make that come to life. So here is part 2, all right, of our development phase, the affordance system. We are going to create an affordance base class, a parent class. If you remember inheritance from your EECS 280, okay, we're going to create a parent class, and this parent class is going to have that interact function on it, okay? Now, we're going to override this interact function. In the parent class, it does nothing. But in the quit game affordance class, the blueprint, it's going to quit the game. In the show message affordance, it's going to show a message, okay? We can override this interact function and make it do whatever we want, okay? And then we can basically just add any new functionality that we want by taking these derived affordance components, these blueprints, and just popping them right onto any object, okay? And that's what we're going to do. However, we're going to do it when we come back in 5 minutes, all right? And a reminder, this is a lot, and it's moving pretty quickly, but when you go back through and create it yourself, it's going to feel a lot better, okay? And you'll get used to what it means to have affordances over time. So I'll see you in 5 minutes. We'll come back and we will, we'll finish off this big part of Project 1, okay? See you in 5 minutes. Ask for a rebate. I got confused by the UI.
Yeah, I should probably take because this thing the mom says like screenshots, but I just like
It's fine. It's good. Yeah. Okay. Okay. Ladies and gentlemen, let's go ahead and get to it. All right. So, we're going to need a few interactable things in our environment. We're going to need some new actors. All right. We spawn right here. We need an exit door. So, let's go ahead and create that actor. I'm going to go up to this little plus button. And I can go to basic. I can go for a, where's our cubes? No, let's go to shapes. Let's go to cube. I'm going to drag a cube out here. Going to raise it up. Going to use my hotkeys to get it kind of in a door shape. Maybe make it a little bit more slim. Push it back into the wall. And there we go. We got ourselves an exit door. Okay. In fact, I'm even going to go give it a name of door. It's no longer cube. I'm going to call it door. Near the exit door, we also want to have a light switch, okay? Because we're going to implement some lights together as well. So let's go ahead and I'm going to copy that door, Control-C, Control-V. I'm going to use my hotkeys to make it smaller because if you think about it, like, yeah, a light switch panel often looks kind of like a, a door, a tiny door. Let's go ahead and make it a little bit more thin so it's not hanging out too much. That's kind of a big light switch, but it's easier to hit that way. And my software is kind of laggy at the moment. Okay, so we've got our light switch, and I'm going to go ahead and rename that and call it a light switch. Okay, and now the question is, how do we bring these two things to life? Okay, when I click on this door, I want to just exit the game. Okay, when I click on this light switch, I want to toggle the lights on and off and on and off as many times as I want. Okay, well, what we need to do is we need to set up that affordance architecture, and the way we do that is by starting with our affordance base class. Okay, every affordance, you've got an affordance when it has that wonderful interact event, that interact function, right? So let's get to it and let's make that. I'm going to get rid of my little search going on here. I'm going to create a new folder. I'm going to call it, let's call this affordances. Inside of this folder, I'm going to create that blueprint, okay? Let's create a new class, a new blueprint class in Unreal. We'll talk about this later, or probably on Monday. But in Unreal, blueprint literally means class. The same darn thing, okay? It's synonyms, they are interchangeable. And so just keep that in mind. If you've got a blueprint, what you've got is actually a class, very similar to a C++ class, okay? What do we want this to be? What kind of class do we want this to be? Well, we want it to be attachable to our actors, like a component. So we choose actor component right down here. I'm going to call this new blueprint class the affordance, capital A. It is our affordance base class. Every affordance will derive from this one. We go inside of it and we say, yep, there's our begin play, looks good. There's our event tick, looks good. But we need that interact event. Where is it? Well, we got to go in, we have to make it, okay? So we're going to go into functions. We're going to click on that plus button. And we're going to say, I want a new function. We're going to call it interact, all right? And if you can believe it, that's it, all right? We have created a new function that is always going to be on any class that derives from affordance. So you've got an affordance class that's about toggling actors. It's going to have that interact function. If you've got an affordance class that is all about exiting the game, quitting the game, it's going to have that interact function. This is a really big deal. Okay? This is called polymorphism. And it's a very important concept. It's one of the, in my opinion, it's probably the best reason to do any inheritance at all, polymorphism. We're going to interact with and mess with and consider and manage all of our child classes just by referring to the parent class. Very, very elegant. And once you understand what's going on, very simple. But it can kind of get a bit meta if you don't quite understand what's going on. That's okay, all right? You'll get a feel for it as you use it and as you use it to build. So we have our affordance class right here, but that's not solving our problem of creating an exit door or a light switch. Okay, so what are we going to do? Well, when I click on this exit door, I want to have a message show up, okay? We'll make it quit the game in just a moment, but we're going to have a message show up. So I want to create another blueprint class, but instead of deriving from the actor component, I'm going to derive from that affordance class. Okay, there it is. It's right there. We created it a few moments ago, and now we can derive from it. We're creating a child class. Okay, and this is going to be an affordance, which is why I put the AFF there, F. But what should we call it? We should call it something very simple and easy to understand. Let's do, how about print message? So AF print message, okay? When we click on it, we're going to see something really cool. If I go to my Functions tab and click Override, do you see that right there? Bingo. That's the magic. We have our interact function is right there. We can click on it, and I can get rid of this if I want. In fact, I think I will. And I can go in, and I can say, I want to print a message. If someone interacts with me, I'm going to print a message, okay? Other affordance components will do other things, but me, I'm going to print a message. What message should I print? Well, we can just start with, let's call this hello from exit door, okay? Hello from the exit door, all right? So if everything is finished, by the way, it's not. When I click on this exit door, I am going to have that AF print message. It's going to run its interact function. And we're going to see what? We're going to see that wonderful message that's going to be, what did we have it? I'm going to go in, edit AF print message. It's going to be hello from exit door, okay? You ready? Let's give it a shot. Okay, here we go. Oopsie. Okay, Y, and here we go. So if everything is finished and we're ready to rock, we're going to see that message pop up, okay? So let's go ahead. I'm still looking at the sky for some reason. Did any of you notice that? Oh, it's not responding. Oh, hello. Hello. I think maybe my computer is, is just struggling a little bit. Let's see if we can get this to go. Oh? Hello? And it's just still looking up at the top of our screen, huh? All right, let's maybe the headset's busted. Hope not. It's getting kind of old. Be bad timing. Let's go ahead and restart the Unreal project. Maybe that's the problem. So let's go to Unreal Engine. But basically, I'll give you a spoiler. What's going to happen is it's not going to work. And the reason is that we haven't quite hooked things up yet. Okay? We've got it almost all hooked up. But we'll have to go through and grab references to those affordances. And we're going to call the interact functions on each of them. That is what's going to hook everything up, and we're going to see that message, okay? After that, we're off to the races, and we can create whatever affordances we want to, okay? So let's give it another shot. Okay, oh my goodness. Welcome to the bleeding edge, everyone, of XR. Let's see here. exit Y. Maybe I can get these going. Maybe we just run standard. Okay, that looks okay. Is Windows Mixed Reality doing okay? You hanging in there? Yeah, let's try and run that. Is this looking good? Yeah, that looks good. Nice and smooth, at least from my perspective. Okay, Unreal. Okay, keep that going. Keep that going. Okay, let's go to VR preview. Okay. Yeah, looks like it's struggling for some reason. I'm not entirely sure why. Can we get this going? Yeah, so we'll go back to home. And yeah, this might just be an Unreal bug or something. I don't think, did I change anything? Let's see. What did I recently change? Anything that could somehow cause a side effect? I don't think so. Let's go to that exit door. Let's take off the component just to see if somehow that messed with it. It would be senseless if it did. They're unrelated. Yeah, if we can't get this to work, then what I'll do is I'll give you last semester's lecture, which I think is recorded, and you can just watch that and you'll finish it that way. Why is VR preview just not doing anything for us? Maybe I need to unplug this, plug it back in. Let's give that a shot. The headset, maybe the headset's just dead. Right in the middle of a lecture. Okay, let's give it another shot. Going back in. Okay, load up. Now, I don't think the headset is dead because Unreal is the thing that's struggling here. All the other things seem to work out. Let's try and open up a different Unreal project. Okay, let's go to the pretzel example from last year. This is, how many of you run into something like this? It's not working, no good reason. That's how it goes sometimes. Remember what we talked about at the last lecture, right? So you are working in a space that doesn't have as many programmers working in it, okay? It has a lot of crazy new stuff going on. And so you're going to run into a lot of these weird issues. And usually you can just get by them, okay? That's cool. I already have everything set up in this example. Maybe we'll just stick with this one. Maybe we will just stick with this project. If going back doesn't help us out, we'll just continue on from there, okay? And I'll kind of show you what you need to do because we're almost at the end anyway. I wonder if maybe our spawn position got messed up. Yeah, we're kind of buried in the ground. Not sure why we're buried in the ground. Maybe, let's see here. Oh, right. Let's go. We're back in the game, okay? That is so XR deck. Okay, so I'm going to do that experiment for you. I'm going to point at our door, and guess what? I click the trigger, so I get the name, but I'm not getting the message, right? And I don't want the name, by the way. So let's go ahead and let's go back into our blueprints. The problem here is that nothing is calling this interact function, so we don't see our hello from exit door message like we want to. We need to go back into our VR pawn and investigate, because you'll see that, well, of course the interact function never gets called. Nothing's calling it. Unreal Engine is not going to call it just on its own. We need to be the ones that go in and actually make it happen. So we'll go into our event graph. You see, when we press the left trigger, we get the display name of whatever we clicked on. But that's not really what we want, okay? What we want to do is when we click on an actor, we want to go in and we want to get all of the affordance components on that actor, okay? So let's do this. Get components by class. And which class do we want? Well, we can specify the parent class, and we will get all of the children, which is exactly what we want. That is the magic of polymorphism. It doesn't matter which affordance is on that actor. We're going to get them all, okay? So let's do that. we've got this array of all of those affordances, and now we want to iterate through each of them. Let's do a for each loop, okay? Boom, just like that. Okay, we'll execute that for each loop, and on every affordance, guess what we're going to call? That interact function, okay? We're going to call interact on every single one of them, okay? And so, hopefully, when we click on that exit door, well, if we look at the exit door, the exit door does not have any components on it. So let's go to affordances. Let's go and add that af print message affordance. And hopefully, we're going to see that message from the door, okay? You'll have to tell me if we get the message, because again, it's so hard to see in the VR. Okay, so over here, click, 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 click. What do you see? Hello from the exit door. Bingo, 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 bingo. You know what's really cool as well? We can use this affordance on other things too. So I can go to this little light switch and I can drag af print message right in, and it will also print a message. But which message will it print? Anyone know? Yeah. Yeah, it's going to print hello from exit door, even though it's an affordance on the light switch. Right? That's not what we want. So what we want here is to make this affordance even more customizable. We're going to go into the affordance af print message, and we're going to create a variable. It's going to be called message to print. And we're going to go ahead and make this a string. Okay, can we make it a string? Is that a thing? Yep, it is. I'm going to click this I right here, and by clicking the I, it is now going to show up. It's going to show up right here, okay? I click on my component, and right in the field, I can actually customize the message that's going to say. This is hello from the light switch, okay? And this is going to be, what's it going to be? What should it say? Let's go goodbye from the door, okay? In fact, I'm going to put this message on multiple times, and I'm actually going to customize the second component. I want it to say, exiting game now, okay? All right, so let's go test this real quick. Okay. All right, so we're up here, and I'm going to click on that door. Click, 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 click. What do you see? Oh, yeah. It's not using the messages because it's not using the variable. Okay, hold on a second. You see, it's printing this hard-coded value. So drag it right out and then use that variable, plug it right in, and now, hopefully, it will use that message that we configured, okay? All right, so let's get our hand up there. Click, 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 click. What do you see? All right, great. So we're seeing two messages because this exit door has two af print message affordances. If I click on the light switch, what do I get? Yeah, right? So it's fantastic. And we can add functionality by just popping these affordances onto the objects. Now, I want an affordance that actually ends the game, because that's what the exit door is supposed to do. Let's go to Blueprint class. Let's derive from affordance, okay, just like this. I'm going to name this af quit game, okay? And I'm going to double-click it. Now, when I override that interact function, instead of printing a message, what we're going to do instead is we're going to use the node quit game. And that's it, okay? We've just finished a new feature. And we can take this af quit game and we can just pop it right on to our exit door. Now, when I click on that exit door, ask yourself what you think is going to happen. Okay, I'm going to click on that exit door. Ready? 3, 2, 1, click. And there we go. We're back. So you see what's happening here. When I click, it says the actor that you've hovered is the door. The door has 3 affordances for each loop. Iterate through each one, call its interact function. When it calls the interact function on af quit game, we quit the game, okay? But what I want to do is the light switch, okay? The light switch is kind of a cool one. In order to care about lights, we have to have a good ceiling, okay? So let's go ahead and make a ceiling, copy and paste, move it over. It's now a bit darker in here. I want some lights, okay? We need some more lights. Let's go in here, point light. I'll drag it right out. That looks really cool, right? Okay, I would have multiple lights that turn off and on and off and on. Okay, so two lights right here. And now, for this light switch, we're currently printing a message. But I want to do something else. I want to turn those lights off and I want to turn them on. So what we'll do here is we could create an affordance called, toggle light switches. But I want to make something a bit more general purpose than that. I want to make an affordance that toggles and turns any actors on and off, any that I want. They might be lights we turn off and on. They might be pieces of trash we turn off and on. A door that opens or closes, right? It could be anything. So let's go ahead and derive from affordance, okay? Again, I'm going to name this AF toggle actors, okay? I'm going to go in there and we're going to find that interact function again, okay? Fantastic, fantastic function. It just works for us. And what I'm going to do is I'm going to say, I want to turn some actors on or off. But which actors? Well, I want to let our user customize those actors. So I'm going to create a new public variable, a visible variable, and I'm going to call this actors, actors2, okay, to toggle. I'm going to change its type to the actor type, just like we did before with the current hovered actor. I'm going to click the I so it becomes visible, and the final thing I'm going to do is I don't want one actor, I want a bunch of actors, right? So let's go to variable type. I'm going to click on this. I'm going to go from single to array, okay? Now what I can do is I can say, hey, all of the actors we're supposed to toggle, let's go in to a for each loop. I'm going to drag the variable here for each, and let's turn them on and turn them off, okay? For now, we're just going to turn them off, okay? So what I want to do is I want to set set actor hidden. Okay, we're going to set this actor to be hidden. Okay, so click the checkbox. So what's going to happen here is it's going to go through every actor in the actor to toggle array, and it's going to make them all hide. So if you click on our, I need to drag that toggle actors onto the light switch. Boom, there we are, a nice component. I can also add a message if I want to. I'm going to do that, okay? I want to print the message, okay? Turning stuff off and on now, okay? And in this AF toggle actors, I have this array, okay? 0 array elements, so I'm going to click plus, and I can then bring these right in. Actually, I think I'm going to give them names real quick. So let's call this wall light, okay? Let's call this wall light 1, and then I'm going to call this other one wall light number 2. Okay, that'll make it easy to find them. Wall light 2. Now I can go to my my AF toggle actors on the light switch, and I can just select them. So let's go wall light 1, and then I also want to have wall light 2 turn off. Okay, just like that. So Control Shift S to save everything. Now I hope that when I interact with this wall light, I'm going to see my lights turn off and on. Well, no, off for now. Click, and they're off. Okay, if I click again, though, they don't turn back on, which is a problem. We also see the message in the corner, right? So multiple different affordances are doing their job and working. And so how are we going to finish this off? Let's go to AF toggle actors. Let's create a Boolean to help us track whether things are on or off. Let's go currently on, okay? Let's go to bool, all right? This is going to start as false, I think. Yeah, I think the initial value is false. Compile. This is an array. We don't want an array of Booleans. We want a single Boolean, okay? And then it's going to start as on. We assume it's on. Okay, so what we'll do is every time we run this, script, we're actually going to set this currently on variable to its opposite, okay? We're going to set it to the opposite of its current value. That means we need a not, a negate, okay, a not Boolean. We'll plug this in, all right? And then we're going to use that Boolean in order to decide whether we should be hidden or not. Okay, so let's drag this in, currently on, okay. If we are currently on, then we will become hidden. But if we are currently not on, then we will become visible again. Okay, so let's give it a shot. All right. Okay, so we're going to come over here. I'm going to turn the lights off. Click. I keep missing. There we go. Turns off and turns back on. I think my controller is glitching slightly. Oh, if I hold it like this, it gets messed up a little bit. Anyway, can I get to come back on permanently? Yep, there we go. Yep. So I think my controller and everything is just lagging a little bit. Anyway, right? So you can see that we've got this new ability, all right? If you ever want to add functionality to an object, like a trash can, or to a light switch, or an exit door, the steps are now really simple. You go create a new blueprint class, you derive from affordance, and then you customize that interact function. When you're done with the affordance, you just drag it right on, and you configure it to do what you want. So it's pretty nice, okay? We have the ability to detect people clicking on things. We have the ability to change what our logic is when you click on a certain thing. And that's really going to help us do things like play a sound effect when you click on the fire alarm, okay? And other stuff like that. Copy a nearby object when you click on the copier, okay? Now, one final thing to note. In this project 1, you'll be creating some new components, some new affordances, all right? But you don't always want to use the interact function, okay? We got a nice interact function here, right? But you can still use that event tick if you want to. You can still use event play if you want to, all right? In fact, you don't always have to create affordances. You might just decide, I just want to create a component. You might go to this block and you know what? I don't want the interact function. I don't need to point and click on anything. I'm just going to go add a new blueprint script component. Actor component is fine. You know, what should this do? Manage all lights in scene. Okay. And now we've got ourselves a component that we can edit and just do whatever logic we want. Don't have to worry about clicking and pointing on stuff. Don't have to worry about interact function, stuff like that. Okay? So I wish you the best of luck on this P1. I think it is a pretty fun project. Please start and get this interaction affordance system going, within the next couple of days. That'll make things a lot easier for you to finish up later. And yeah, if today and what we went through is a bit overwhelming, remember, you can go watch this recording. You're probably going to. You can follow all the steps, and things will start to click as you build more components and you realize how powerful that interact function really is. Okay? You really have gone in. What we did today, we went in and we created a new lifecycle function. Event begin play existed. Unreal provided that for us. Event tick provided for us. We just created a new one of these, interact. Okay? And it's very powerful stuff. So, everyone, I wish you good luck on this project. Please have a fantastic weekend. Please let us know if you run into any issues. Remember the hints column on that spreadsheet, okay, for all your tasks. And I'll see you next time, okay? We got office hours tonight from 6 to 8 p.m. I'll be right here. You let me know if you have any issues. Okay? I'll see you later. Bye-bye. All right, everyone online, take care. Oh, I hope it was recording. Yeah, we'll have to see. I think it's still getting my voice. All right. See you, everyone.